This is day 3 of Unit 6. We started today with a warm-up. So there's the warm-up. So pause the video, take a couple minutes to complete that, and then play to check your answers. So the first one is similar to what we did yesterday. So we first look at the denominators and figure out the least common multiple between x squared, 4, 8x, and x, and we hopefully figure out that that's 8x squared. So I'm going to rewrite this with multiplying both numerator and denominator by 8x squared over 1. So I have 5 over x squared times 8x squared over 1 minus sign 3/4 times 8x squared over 1 all over 2 over 8x times 8x squared over 1 plus sign 4 over x times 8x squared over 1. So looking at the diagonals, the x squareds are gone, the 8 and the 4 are gone, the 8x and the 8x are gone, and I'm left with just an x there, and the x's are gone, and I'm left with just an x there. So let's see, I have 5 times 8, which is 40. I guess I'll just write that over here, minus sign. I have 3 times 2x squared, which is 6x squared. And I have in the denominator 2 times x, which is 2x, and then plus sign. 4 times 8 times, or I'm sorry, yeah, 4 times 8 times x, which is 32x. So I'm noticing there's a 2 in common here among everything, so I can just divide everything by 2, which gives me 20 minus 3x squared over x plus 16x. Or I could have combined like terms in the denominator first. It doesn't really matter. So I'm getting 20 minus 3x squared over 17x. I don't see any common factors now that I've done that. Now all I need would be domain restrictions. So I look at the original denominators and I look at my final denominator. Whoops, sorry, I don't know why we have an x squared there. That should just be 17x. That's just 16x plus 1x is 17x. I was going to say there's no squared there. But anyway, I look at my final denominator, 17x, and my original denominators, and I'm realizing that x cannot equal 0. So 20 minus 3x squared all over 17x, just a 17x, and x cannot equal 0 is my final answer. This one here is really just to help you remember the process of adding fractions. So we know to add fractions, we can either just go right away and get common denominator, or some of you may have noticed that 4/6 simplifies to 2/3. So I can simplify it first. So now I'm looking at 3 and 4 denominators and looking for the least common multiple, which is 12. So if I want this 3 to be a 12, then I have to multiply 2/3. I have to multiply the 3 by 4 to get the 12, which means I have to multiply by 4 over 4, because I don't want to change the problem. If I just multiplied by 4, I'd be changing the problem. But if I multiply by 4 over 4, that's 1. So 4 times 2 gives me 8. Plus sign. Now I'm ready to get the 4 into 12ths. So 4 into 12ths means I have to multiply by 3, which means I have to multiply the numerator by 3. So I'm multiplying by 3 over 3, which gives me 9. So 9 12ths plus 8 12ths, I know, is 17 12ths. And I don't see any common factors, so that is my final answer. Okay, now that was obviously very easy because you learned how to do that many years ago. The point of doing that last problem in the warm-up is for you to remember the steps and realize that those exact same steps that we followed there in number 2 are the same steps you would follow if I throw variables in there as well. So I still want to simplify any of the fractions or the rational expressions if I can first. Then I want to get a common denominator, because I'm trying to add fractions or rational expressions that don't have the same denominator. So I have to get that common denominator. After I get that common denominator, I'm going to add the numerators, just like we did here, 8 and 9, and I'm going to keep that denominator. And then lastly, I'm going to check to see if I can factor that any further. If so, I will. If not, I'll leave it, which I did here in this problem. So as I said, the steps would be the same if there's variables involved. So example 1, we just took some time here to figure out the least common denominator. So basically what we're doing is we're thinking of this as a denominator. So if something is in the numerator, it doesn't really matter what. Something else is in this. This is the denominator. So I have 2 different fractions and I'm trying to add or subtract them. So in order to add or subtract them, I need to figure out what the least common denominator would be. So the least common denominator, if x plus 2 is one of the denominators and x minus 3 is the other, the least common denominator would be those 2 multiplied together. And you don't have to multiply it out, just those 2 factors multiplied together. So B, between 4 and 8, those again being denominators, we know the least common denominator is 8. And then x plus 4 and x plus 2, well, they're different, so I have to include them both. So that would be the least common denominator. Here, between 4 and 1, 4 is the least common denominator. Between x and x squared, we did one like that yesterday. We know it's x squared. And then between x minus 1 and 1, well, we know we have to include an x minus 1. So 4x squared times the quantity x minus 1 is the least common denominator. D. So here, we have an x plus 2 that's in common. So we're only going to include one x plus 2 for the moment because we're including the one that's in common. But then the x plus 2 and the x plus 3, which are not in common to both, but they are part of each of the denominators, they each need to be included. Just like in this one, we included both the x plus 4 and the x plus 2, and this one, the x plus 2 and the x minus 3. So x plus 2 for the one that's in common, and then x plus 2 for the one that's not, and then x plus 3 for the one that's not in common to both. That would be your least common denominator, or if you wanted, you could write x plus 2 the quantity squared. Okay, so now that we understand how to find the least common denominator, let's try this one. So you want to copy that into your notes. So we know step 1, if we're following those steps that we looked at a moment ago, is to simplify any of the fractions or rational expressions that we can. Well, I can't simplify unless I factor first to see if there's anything that I can simplify. So let's go ahead and factor both numerator and denominator here. So negative 1 comes out, and then we have 2 plus x, or that's the same thing as x plus 2. And then we have here factoring x plus 2 and x minus 1. And then I can't factor the next rational expression. So hopefully you're now looking after you factor to see if there's a common factor, and you're noticing that there is. X plus 2 and 2 plus x are the same thing. So I can factor that out. And that actually helps me a lot, because factoring that out, then I'm just left with negative 1 over x minus 1 plus sign x minus 4 over x minus 1. And me doing that, factoring that common factor out, and now I don't even have to get a common denominator because I have one already. Had I not realized that and not crossed off the common factor, then my denominator is x plus 2 times x minus 1 and x minus 1. So then I'd have to do some work over here with this rational expression to get it to have the same denominator or common denominator as the other one. But me crossing off those common factors helped me to realize I don't even need to get a common denominator because I already have one. So be on the lookout for those shortcuts because that'll help you. So x minus 1 is the denominator that we keep, and then we're combining x minus 4 plus negative 1, which is x minus 5. Looking here, remember you cannot cross off x. It's not a common factor because it's being subtracted, not multiplied. So I know that's my answer, and now all I need to include would be the domain restrictions. So looking at the final denominator, x can't equal 1. Looking at the original denominators, also negative 2. and 1 again. I don't have to write it twice, and 1 again. I don't have to write it again. So that is my final answer. Next, so once again, we know we're going to factor first. So after you have that copied in your notebook, go ahead and pause and try and factor these denominators both. So let's see here. We know this is factoring into 3 and 1 and looks like plus 3 and minus 1. This is factoring into, looks like 3 and 2. Looks like plus 3 and minus 2. So now we have them factored. We're going to check to see if we can simplify anything. No, unfortunately this time there's nothing that factors out. So that means I am going to have to get a common denominator. So I'm looking at x plus 3, x minus 1, x plus 3 times x minus 2, and I'm figuring out, just like I did in that problem a minute ago, figuring out what the least common denominator is. So there's an x plus 3 in common. So I know I'm going to include one of those. There's an x minus 1, and there's an x minus 2. So that is my least common denominator. So I'm going to write that. I'm going to put the minus sign. I'm going to write it again. And now I'm going to figure out what I need to do to get that as the denominator. So if you think back to that one we did a moment ago, 12 was our, in the warm-up, was our least common denominator. So we had to figure out how to get 12. Same thing here. I have to figure out how to get this denominator when this is the denominator that I had. So the quantity x plus 3 times the quantity x minus 1, and now the quantity x plus 3 times the quantity x minus 1 times quantity x minus 2, I can see that old denominator was multiplied by the quantity x minus 2. So I can't just do that. I'm changing the problem if I just multiply the denominator by x minus 2. But if I keep the numerator that was there and I also multiply the numerator by x minus 2, then remember I have x minus 2 over x minus 2. So now I'm taking the old fraction that I had and I'm multiplying it by x minus 2 over x minus 2, which is legal in math terms. It's okay. I'm allowed to do that because I'm just multiplying by 1. So that's okay. So I'm going to do that. Same thing over here. I had 4x. Now I'm looking at old denominator, x plus 3, x minus 2, x plus 3, x minus 2. What changed from here to here was the x minus 1. So I'm going to multiply both numerator and denominator by x minus 1. So x minus 1 over x minus 1, I am multiplying by 1. So now that I've done that, I can keep my denominator. And I'm going to combine the numerators by subtracting. Okay, well, in order to subtract the numerators, I'm going to first have to distribute here so that I can subtract. So we're going to be distributing that 3. Now here I want you to be careful because think about this. This is subtract everything that follows. Everything that follows that minus sign is going to be subtracted. Well, that gets a little bit tricky. And the reason it's tricky because it's hard to remember once you have simplified this here, distributed the 4x. It's hard for a lot of times students to remember that you're subtracting everything. So to avoid that problem of remembering that you're subtracting everything that follows the minus sign, my suggestion is make it addition. And then because I made it addition, I have to change the sign to a -4. Remember, subtracting is the same thing as adding the opposite. So I'm allowed to do that. But the reason that's helpful is because now I don't have to remember after I've distributed, I don't have to remember to subtract everything. I can just add and then distribute as I normally would the -4x. So that's what I'm going to do. So 3 times the quantity x minus 2 is 3x minus 6. And -4x times x gives me -4x squared. And I'm adding that, of course. And -4x times -1 is +4x. And again, there I've already worried about that subtraction. I don't have to now remember to subtract that. So next I'm going to combine like terms. I have a -4x squared. I have a +4x and 3x, which is 7x. And I have a -6. And that's over top of that same denominator. Okay, and so next, remember the last step is to simplify if you can. Well, I can't tell by looking at this if I can simplify because the denominator is factored and the numerator is not. So the first thing I have to do is factor this if I can That way I can see if there's any common factors that I would factor out. So let's see if we can factor negative 4x squared plus 7x minus 6. So negative 4 times negative 6 is positive 24, and the middle number is 7. So numbers that multiply to 24 and add to 7. So think through that. I don't think there are any numbers that multiply to 24 and add to 7, which means this numerator does not factor. Because it doesn't factor, then I don't have to factor it and check for common factors between the numerator and denominator. Keep in mind, if the numerator did factor, I would factor it, and then I would look to see if there's any common factors. If, let's say, I had an x minus 2 in both the numerator and denominator, I would be factoring that out, crossing it off, and that would affect my answer. So this is going to be my answer, but now I need my domain restrictions. So I know x cannot equal, I'm going back up to the originals, negative 3, positive 1, positive 2. Negative 3, positive 1, positive 2, and then looking at my final answer, there's no others. So that is my final answer. Okay. All right, your homework for tonight is all of worksheet number 7 in Unit 6. And you're going to do the odds on both pages 5 and 6. So the odds on page 5 and the odds on page 6, but all of worksheet number 7 for tomorrow. Next week you have a quiz coming up on Monday.